How's it going, everyone? Eulier Gonzalez again. Today, we're going to take a look now at a quick recap of all of these performance optimizations that we can do uh, in our React application. Why is that? Because if you can now is write performance React components, therefore you are going to be able to have a very performant React application. So because of that, we're gonna jump it straightforward into who is the instructor of this course, which is Steve Kinney, head front-end engineer at Temporal, which is this durable execution platforms uh, that companies like Virtual actually are using. And because as a way to understand how you can optimize something, you need to understand how that things work first. That's why over the couple 2 months, I have dedicated time to actually understand how React actually works behind the scenes. So by taking a look at the React Deck docs, especially the elder sections, and understand all of the theory as well as put at practice as a way to describe the UI, how you can now add interactivity to this user interface, and then how you can manage the state of your applications, as well as the escape hatches, or how you can now make your React application, React components to connect to connect, control, and sync with external systems using useRef and their use cases, as well as the effect and their use cases and the anatomy of that, as well as the thing that we're going to do most of the time when we write our effects. What are the particular buckets that it fill in, or the particular patterns that actually when we use or when we write an effect actually uh, fit in, and also how we can think of our effects. And as we started to write our effects, how important it is to know when this effect is getting triggered, in which part of the rendering mechanism this component or this piece of this custom hooks, this built-in tools, how it fits during the entire rendering mechanism. And from that, so now that we know how actually everything works here behind the scenes, as well as how you can make your code to make it reusable by using its custom hooks. Uh, Now we're starting to understand and see what are the particular recipe that Steve Kinney mentioned when it comes to actually perform or to improve the performance of your applications in React. So first, look at the production build. If that is using the production build flag, great. Then focus on how now the components hierarchy and the states are laid out. So start from there, which is something that we focus our attention here. But this is React TypeScript. Now we want is to take a look at the React performance. Exactly. All right. Uh, and once you look at that, then uh, see how you can now use Memo for that, if it is relevant to use Memo in your component as a way to only tell React to re-render these components when this change. So when the properties of these components actually change, and how it's important is to understand, well, as I mentioned before, the component hierarchy and the structure of React. So, and one of the golden rules of Steve is that not doing things is much faster than doing things. So, why is this important? because as we move down, for example, of the techniques that we need to look as a way to reduce rendering. So by understanding is how now React works, understanding is the VDOM as well as the React Fiber. What is the capability that React Fiber is providing to us? What is this, at least from their docs, what is the React Fiber is aiming to do, which is pretty much like the stack, the call stack, but instead for function is for React components. So this is called the virtual stack frame for React. And now, once we at least you understand this basic notion, you can see, or we can get here a more practical approach of how can we now reduce rendering. So first is you can push the state down the tree, okay, or make the component tree hierarchy as small as possible. The other is that pulling the content up with children's. So when you define is your components at that level is when React, when they call that components, when you define your file. So when you import a component, those components will get rendered based on where in which file you define that. So in other words, it means that that's one of the reasons why they use here is pulling content up with children, okay, as a way to prevent the components to get rendered. And there's some other technique here that we can use as a way to now indicate, hey, I want you make use, or I want you to only get trigger these components whenever a dependency changes. So for example, they use callback and use Memo. The use Memo is as a way to now catch this computation between re-rendering, or use callback is to catch this function between re-rendering. And even though that we're using that because we want us to now see how can we actually is stop or let the React not compute those components, or stop the computation there. That's what we're starting to see is now the useReducer and use dispatch.
Microprocessor have been done, we're left with like the weird squishy that is probably a bad idea. So,
and that's exactly what we're gonna do in today's video.
This is where another thought exercise that like literally considered and thought about and then opted not to do because I think that it's probably a bad idea. So these packed and unpacked items are generated on the fly, right? They're generated from taking the overall list and you filter them, right? If there were a lot of changes that didn't involve them moving back and forth between the two lists, right? One thing I could do is I could wire up my state management in a way that had two lists, right? And then I would manually have to shuffle them back and forth, right? And you'd want some unit tests for that. Like even in that simple example, you'd want some unit tests. And then I could then memoize, or have things based on each of those. But then I'd have two of each of those add, update, and remove functions. And I would have to like do the active shuffling them back and forth. And sometimes like, one, I don't actually know that all that extra work and having double of everything and volleying stuff back and forth is worth it. And two, the complexity cost is also probably not worth it for almost no performance gain, right? But again, you have options, and to like always reach for one thing blindly is probably like at least slightly problematic, right? But you can also again see like you can get a look at that flame chart and be like, are the things that I'm expecting to render or re-render actually doing that in this case, right? One thing I'm curious about too, just to look real quick, is I would expect an individual item isn't. They're getting a new update and remove. So could we make this better? I think we could. Let's do it.
All right, so let's get into this. Yeah, this is the packaging list. It's gonna open up here. There you got it. So the whole point of this is to see how can we now improve is at least the perceived performance with this, right? Which is instead of actually anytime. Okay, so instead of actually anytime we click here and we now refresh the entire application like this and this and this. And also it is funny because we also are now rendering is this. So we're actually affecting is this. And that's something that we don't want then. So we take a look at our profiler, and take a look at this and say, hey, let me actually keep track of this and this and this. All right. So I think if I, for example, zoom out here, like this, as you can see, it say, hey, the application changed, and this item list actually changed, followed by this item list. So actually, we are sharing that item list component, okay? And because the property changed, here also is some of this actually change as well. Right? Similar for this. It's like, hey, actually one of them actually changed, and the same for this. Mark all as a package. So the question is that how can we do this better? And I don't know why this actually showing like that. Okay. All right. And you do this and this, and you stop it, and as you can see is this, right? So the application now is here calling this, and the thing is that because they are changing, the question is that can we do this better, right? Prop change actually here is, even though header is actually changing here, which is quite interesting because we don't want to do that. But as you can see is this, right? So both of these actually that are using Memo, okay? But even though it actually is rendering is all of this element as it is. The question is, can we do better? Yes, we can.
All right, as I said before, we get a new update. If we pass either set items or dispatch all the way through, like those stay static, they don't get regenerated based on items, right? But then the problem with passing set items through is what does it need? I mean, theoretically, it needs a list of items unless we use the function callback. So let's do it. I could do it either way. We'll get the same effect. Let's do it with a reducer, but also passing set items through and using the function callback would work. So check it out. It's almost like I had. I mean, theoretically, it needs a list of items unless we use the function callback. So let's do it. I could do it either way. We'll get the same effect. Let's do it with a reducer, but also passing set items through and using the function callback would work. So check it out. It's almost like I had pre-baked reducer. It does all the things that you think. It adds stuff, it removes stuff, so on and so forth.
Mm-hmm. You actually have everything pre-baked here. Okay, with all of these functionalities here.
So in this case, what we'll do is we'll change this to useReducer.
Where initially it takes the argument like
I'll give it that get initial items.
The initial state. That's right.
Which is literally just returning a JSON array. I don't even know why it's a function. And so this becomes called items. Yep, and we'll call it dispatch now. Now, dispatch just fires actions. It doesn't actually need to know what the current items are. It's just saying.
So dispatch is just actually dispatch actions.
Like, hey, this item, we're toggling it, right? And the reducer gets everything and figures it all out, right? As we know that set items, if we still had it, you could do this as well. It's really like, they are set state being or use state being an abstraction over useReducer, it's not even like, even to call them different things, you could do it either way. It's different flavors of the same way. This would give you a reference to the current items that you would not have to pass through. But I think, like, yeah, no, you could do it. Like, you could do it for some of these, and make it all kind of happen, right? I'll leave that one as exercise to read it. Let's do the useReducer because it's just different, and I can make a point. And you can do stuff with the items here. So now we're going to pass dispatch all the way through, which means really I get to do one of my favorite things in the world. Can't delete the two lists.
And because we're using useReducer to dispatch these actions down there.
That one.
There.
And we can see that instead of passing all these things through, we literally just say,
because this is only a function that only takes care is that you're going to send an object here. It's not triggering anything.
Do it here as well. I'll pass it through the others. I'm probably only going to do the two lists in front of us because it's just variations on a theme. So we'll pass it to item list. In item list, we will go ahead. Really didn't need that in another pane. We'll swap out the fact that we're giving it update and remove and just give it that regular old dispatch. And notice I got rid of all those use callbacks that I wrote.
Exactly. You just get rid of all of this use callback here, and you're just only passing this dispatch, where after all, this is an object, okay, or a function that only get triggered.
They're gone
when you use
right. So by definition, like this is going to be slightly better for us. And then the individual item.
When you're gonna get used to that.
Getting an update and remove. I literally have it on my clipboard. Cool. And then we'll go down one deeper. Get rid of it again. Now, insofar that I'm very lazy, the action creators have the same names, so I just need to import them.
That's one of the lovely things. Similar to this.
So now the only thing coming through is dispatch. So that now wraps each of these.
So you have to wrap this, because why is that? Because now you're going to send is this action object like to the dispatch function as a way to say, hey, now this is the action that we need to, and this is the state and the data.
These will dispatch those objects. It doesn't need to know anything about the items. It's just telling the reducer, hey, they said they wanted to remove the one with this ID. The reducer's like, yeah, I got all the items. I'll figure it out. I think that I'm like accidentally getting myself like the reputation as like a reducer fanboy, and I'm here for it. I don't have a problem. So let's check it out. You see that I don't have the individual items flashing anymore, and we'll verify that in the tools. Right, like, sure, the first time it was rendered, like probably once it changed, but you can see at this point, like it is not re-rendering them because they're getting the same dispatch. They are the
except because they get the same dispatch, they got the same reference in memory.
The same item in memory, because just because you change something, the array is different. All of the objects in that array are the same ones unless you change them.
So you're not recreating, it's a new collection of that.
Right, that's part of the promise of like the immutability. It's the same object, so that was fine. Just because it was a new array full of objects doesn't mean the objects were different. It's just a new box that they're in. And so we got rid of all the use callbacks that we just installed. All we have is that React memo that we had in the very beginning.
Exactly, so you're using, of course, React Memo.
And yet, we actually stopped an entirely additional, like removing a use callback and taking a different approach was more performant than using the use callback, right? And that's like kind of a running theme that we have today, which is like, sure, these tools are great, but are they the best one, right? Sometimes they are the right one. Sometimes the trade-offs are worth it. But just being like, oh yeah, I have to do this blindly every time is maybe not always the best way forward. And like we could do it with set items too, right? Like, and if you hit some of the ones I didn't fully wire up the dispatch with SSA, they will break, so just don't hit them. Now this now gets, we'll give the function version where it's like all the items. I'm only going to wire up this one just to make the point. Mark's question. Oh, we broke it. A new version of this function. Dispatch is always the same one, right? It doesn't ever change. It is from the very beginning of when you call that hook, it gives you a dispatch, which will always be the same dispatch. So it eliminates your need for use callback completely. The only reason we needed use callback is we were whipping up functions on the fly. If we were willing to pass down, like either the set items or dispatch, they're effectively used callback way before we ever got it, right? Here we're taking something that was already used callback and wrapping it in another one, right? So it's not necessarily that like they're better morally. They're just like doing things less is better than doing it more. Yep.
Is there any performance advantage in using Redux over how you're using the reducers here?
Yeah. So like everything, it depends, right? Also, I called it name for some reason. We're doing packed on this one. That's what happens by talk and type. But so yeah, the question was, is there advantages to using Redux? So there are advantages to using Redux, right? useReducer is great. Awesome. You get a reducer, you get dispatch, cool, cool, cool. Things you don't get, middleware. Things you don't get, Redux DevTools.
Exactly. Which is part of the reason of what I mean. You can use useReducer for that, but again, in contrast with Redux, you don't have middlewares. You don't have the time travel debugging.
A few other things. Things you don't get is like all of the TypeScript support that's built in React Redux. When we imagine once we get this thing not rendering, that we're going to pull it, just hypothetically, that the next section was like, let's wrap this thing in the context API, right? You will see that all of the performance gains that we got immediately go away, right? We'll get them back by doing a bunch of work, right? If you were to then do the same example as an exercise as a reader like later and just grab React Reader, does the simplest version, you would see that you would have all the performance gains out of the box for free, right? For two reasons, right? Some of them are newer reasons than older reasons, right? For two reasons. One is that like those performance gains have been done for you. Two is that modern React Redux, at least the current version, I don't know when this changed, but I verified it by looking at the source code like a week or two ago. It doesn't use the context API. It uses that sync external store. It literally like almost typed it. Have been done for you. Two is that modern React Redux, at least the current version, I don't know when this changed, but I verified it by looking at the source code like a week or two ago. It doesn't use the context API. It uses that sync external store. It literally like almost typed it a second ago. And it uses that, which is like, because by definition in React, that useReducer is a hook, which means it has to be defined in that function, which means the store, at least, or that state, is new every time, right? You think about when you set up Redux, you're saying like out even before you like did your first component, even before you created that root, you're like create store, right? So that is a static object that is just floating there, the same one in memory. It has a getState method and a subscribe, which just gives, tells you to call getState, where it'll give you the newest and most immutable version. If that state hasn't changed, you automatically get the same object as you got last time. It's only if it changed that you get a new object. The store itself isn't going to change because it's in the initial scope that you defined it in. So like, it is just simply like, it's better insofar that like useReducer doesn't seek to be a complete replacement. It seems to be like in that like there's always the like there are certain distances that you will definitely walk to and you'll be like, I'm not taking a car there, right? And then after a certain point you're like, I'm gonna either get the bike or the car or something like that. And I think like useReducer is like, I need a little bit of a reducer. I need something where I've got like a form and like multiple things changing and I'm like deriving the state at the end. Pulling in Redux at this point feels like a bit much, right? Or what have you, state management library of choice, right? I like Redux, cool, cool, cool. You might like MobX, what have you, like cool. But there's like usually sometimes it's like, is it really time for this yet? Yeah.
Yeah, when I combine.
But it all boils down to how immutable is this object. It is how this object is the same. Even though that you now change the properties inside of that, the reference in memory remains the same. So what happens is that anytime you now re-render a component or actually re-render a component, which is using JavaScript behind the scene, as a way to call these functions over and over and over and over and over and over, what happens is that inside of the body of that function, once you do that, it will recreate that it will recreate that object in a different space in memory. And that's exactly one of the things that we don't want. That we want is to have now that reference in memory stay there and only change its values for that. but we want the reference be the same, because when you change that, or when you need to, or when the JavaScript need to allocate in a different place, of course this becomes a new object in memory, and that's why we have, for example, things like in this case, say, hey, is this a depend of the object? All right. Say, hey, I want you to evaluate depend of the object. It say, of course they're not the same because they have pointed to different locations. They have different space in memory. They have different boxes in your drawer. All right. It's like, hey, this is the space I reserve for this object in the drawer, and this is another space that I reserve in the drawer. That's why they actually doing is this. That's why it's actually doing something like this. A type of null is an object. This is, well, that's quite interesting. And undefined, it's an undefined except for the type of and that kind of thing. Okay, so, but in any case, yeah, in any case, and this is something important to understand, because that's why now the React actually is holding that. And that's why you're going to see a lot of the time problems in your React components, or problems when it comes to rendering all of these components. So because of that, and this is now different reference every time. So JavaScript is actually assigned as a different space in memory. So you have your drawer. So JavaScript say, no, this space here in this drawer is reserved for this particular object, and similar to this another way. So what it's doing is to actually is using your memory to allocate that object or place. Again, pretty much like you have a drawer or in your fridge. Okay, when now JavaScript actually, or when you, for example, if you want to store, let's say each one of those objects here are fish. When you want to have is now, you want to store fish in different bags, all right, or different any other recipe, any other recycled recipe in your fridge. Both of them, they are not the same, even though they are fish. Okay, even though they are objects, you know they're not the same. You have now different space for each one of them. That's one of the reasons why it's a false here. So unless you define is this, and then you say, hey, let me define as an object one here with name like you, John, okay, like John here, and then you say, hey, I want you to define is an object 2 that will be is a reference of the object 1. Okay, and then you want to compare is now the object to the object 2. Of course they are different, but in this case, because you have now a same reference to this, of course they are true. So if for some reason you want is to now reassign it its value, okay, which is something that of course you can do. But for example, if you say, hey, I want you to now say object.name will be is the, instead of John it will be Joe, this will be actually be reflected on the object 2 as that, right? Why is that? Because now they have they have the same reference to that particular object. So whenever that changed, it changed. And you may wonder, wait, but I define this as a cons and cons. What you're telling to JavaScript is that you're gonna make their values which is an object, which is a referencing memory, the same. What you just change is just the content inside of that, but the reference, but the slots in memory are the same. The slot in the drawer are the same. So this is quite interesting. This is a very, very interesting. Yeah, this is a very, very interesting topic. So now it is time for us to see how can we now improve that. So by looking now at the application here, I think it is. It's interesting. So by looking at the application here, and instead of using its callback, take a look at this. So instead of using now callbacks here, all right, like remove, update, and add, we're just going to use now is a reducer, okay, which is something that you define here. We create now is our reducers. That's quite interesting. That it defined then as a TypeScript. What is this? This is not a TypeScript thing here. But in any case, you got your reducer here. That will have is all of this. They're using is create React tool dev toolkits for that's item add, that is remove, create action mark all of unpack, and all of this, right? Create items, update items, remove items, and map. And this is something that comes from here, the items itself, which is a nice little convenient functions that actually is going to like this. That actually convenient functions that is going to actually is the one who going to perform the new state, right? For example, update items, remove items, filtering, filtering by property, and that kind of thing. Okay. All right. Okay. So because of this, we got all of our reducer here. For example, and they're using is now a wrapper of Redux toolkit as a way to do this. To uniquely identify that. So instead of your reducer, what it did is just receive the state. If you don't receive any state, you're going to receive that now as a default state, similar to the action here. And the action is that this object defined here, okay, that this object can be is a return type of add, and here they're using is now TypeScript here, a type of add, okay, return type of update or remove or mark all as unpack, right? So it can be one of those state, and each one of them has a different particular payload or shape of the object. It's a hey, it can be either this, for example, the add here, I just want to get is the return type for that, which to me is quite interesting. Similar to this, the update, it's the same for the remove and that kind of thing. So this is just another fancy way to actually create your reducers. But remember that after all, this function here is the same. So your reducer function is the same. So you have singletons, you have one reference do this once you build your entire application. And also is that dispatch functions, okay? So your dispatch functions, take a look at dispatch functions. But this dispatch function but this is something interesting. You can call dispatch with an object representing what the what the user did. Exactly. Because when you're writing your reducer function, it's like that. Avoid recreating the initial state. So in any case, the idea of this reducer here, as we have that, is to, now that we have one single reference here object, okay, and since we have now the single object here, and what we're doing is now calling that object, which is the same in memory, so we're preserving is the immutability. That's when we are now have the ability, when we change is, for example, this use callbacks and all of this, how can we remove all of this callback here? The same for this, okay? And then we say, hey, let's go to actually use is the dispatch property and pass the dispatch here. Of course, it's complaining because we need to change this to use reducer, another Boolean hook, and say, hey, get initial items. I think it is the function that they're using here. Get the initial item for that. Get initial items in your reducer, which is, you say, hey, I want to pass this the initial the initial state, which must be in our reducer here, or I'm assuming that must be in our reducer. Type reducer here. Okay. I mean, if we need to pass is the reducer function, my bad, sorry. Which is the reducer here. Reducer. We need to pass is the reducer function. Okay. And no, it didn't import that. Use Reducer here. And here this is called now as the dispatch. Okay. This particular function that we want is call whenever we meet and pass this function. And when we call this function, dispatch, what it's doing behind the scene is calling is the reducer. So React will set the next state of the reducing of the result of calling the reducer function. Exactly. Because this dispatch is now calling the reducer function, and the reducer function is the same object in memory. Okay. Oops. And reducer is the same reference, is the same object in memory. It's on the same spot there, and by passing down that all of this, for example, to the new items here. For this, we need to pass this now. This add items here. That instead of doing this, you say, hey, I want you to add this new item. Okay, and we're going to pass this now the dispatch here, where this dispatch is actually gonna call that add item. For some reason it doesn't know how to complete that, no problem. Okay, add items here. Ignore reducer. Create, update, and remove. Okay, the items here. That's right. Remove item, filter items. There's nothing. There is no add items. That's not good. By the way. Yeah, that's not good. Okay. Interesting. Okay. Oh, you're gonna pass this the create items. Okay. Okay. So in the new item, you're gonna pass is that. Exactly, we're gonna pass is this to the item list. We remove is this callback here, followed by this, and the same for this. We're gonna pass is now the dispatch. On each one of them, each one of them, now what I'm gonna here is to receive the dispatch here. So the dispatch, okay. And by calling this dispatch in our event like set filter item list, oh, there you got it. To here, instead of actually passing down that data to that, in the empty space here, okay, as the key here, in our items, we're going to is now send the dispatch here and actually wrap this into this dispatch function. We of course need to update that from the reducer for all of these actions that we want to dispatch. Similar for the update. So what it's doing, this little function is to just abstracting. So by passing now this function as a way to return is the proper actions that is going to be used by the reducer for that. And remember, the reducer only have one reference in memory, which is something great that we want to do. And because of that, because it has now one single reference there, so now, and of course you say, hey, you crashed this. Well, let me save this. That's right. You say on the application here. Oh, and let me actually also here, and then mark as well. Instead of on click, you're gonna have is a dispatch. Mm-hmm. Oh, it's because of the way how we are initializing this. Yeah. This stay initialization. Okay. All right. So if we take now, oh my God, that was interesting. It's the way how we are initializing this other state. Okay, and I could detect that quite straightforward. Good. So now it's time to actually check this. And as you can see, now it's no longer doing that. So you take a look at the flame graph. It's actually not rendering is this any of this item. Similar for this. Of course, new item here, and when I click there, it did not render because the props does not change. Similar to this, it's not rendered because now the props don't change, which means that you don't need to actually call these components and therefore pass through the rendering mechanism. And that's quite very interesting as a way to understand now this. So what is happening here is because it's not rendering this, because since this has the same reference, especially when you click down there. So if we take a look at this, especially if you click down there, so you are dispatching is now that particularly. So you are calling that function that is in memory, that is there, hasn't changed. It just generate a new bit of a state for that. Therefore, you are not calling that component. Therefore, you are not calling that component that trigger that state updates, because you are not recreating it, because you have the same reference there, because that function here actually now calling to the same reference in memory. And I think that's quite very beautiful and powerful. Totally. So this is quite interesting here. Mm-hmm. Exactly. And that's part of the immutability here. Make sure to take a screenshot of this. Oh, you actually see that? No. Okay, I get it. There you got it. Okay. So because of this, that's a part of the immutability here. To represent your state to avoid re-rendering, use Memo and callback with useState. useReducer and dispatch with useReducer. So the thing here is that because of this, so since dispatch is calling a function that is the same. Since dispatch is calling a function that is the same in memory, we are not triggering is re-rendering. Exactly. We're not triggering a re-rendering. That's because, so that is the promise. That's the promise of immutability. That's the promise of immutability. as long as the array doesn't or as long as the data structure, whether it is the array, for example, array for this example, exactly. So as long as the data structure doesn't change in memory, okay, we're not going to trigger that. Mm-hmm. Is E or event? Okay, now it's using is the callback. Doing the thing less is better than not doing. The question is that if you don't use Memo, for example, if that works, if we don't use Memo, for example, it still works. That's a valid question. I want to use the profiler here, so we'll just say this. Interesting. So what happened is that all of these items are getting rendered. What does it mean is that it's detecting that you're receiving is a different. It is quite interesting because now it's detecting that this component is receiving okay. It's a dispatch function change. It's because it's receiving a new props. Okay. It's because it's receiving a new props. But what happens is that if this new prop that you receive is the same, because at the end of the day, dispatch is just calling this function that is calling a reducer, that this reducer is the same space in memory, so therefore the values doesn't change. So for example, if we do this again, it's because by calling that function, of course, is not changing that. That's very interesting, and that'll be all for today's video. Take care. Bye bye.